Okay, gang, good morning. Happy Friday. We're jumping in right here to class number 12. This is Applications of Systems Day 1. So what today is about is a bunch of word problems. And as we set up these word problems, we're going to translate all of the words into two equations with X and Y or two other letters. And then we will solve those two equations using the techniques from our last class, which you did in the homework, substitution method, and the elimination method. You can see that coming up in our next class, we have day 2 of exactly the same thing. So we got 2 days of this. The word problems we tackle next class are going to be a little bit tougher than the ones from today, but it's still the same idea where we're going to set up two equations in two unknowns. So our next class you can see is not until October 11th. That's because this coming Monday is a holiday for GCC. It is Columbus Day. And so there are no day classes on October 9th coming up. If you have a Monday night class, though, that is on as scheduled. So next week, we'll meet on Wednesday for some new stuff. On Friday, a week from today, is our review for test number 1, which is coming up on Monday, October 16th. Test number 1 covers lessons 1 through 13. That is to say, everything for the entire semester, including our very next class. We're a little bit before the middle of this semester, but that test number 1 is pretty darn close to being a midterm for us. We've got 2 tests and a final exam, and this is basically the midterm. So definitely not too early to start studying for test number 1. You got the same sources of problems that we've talked about before, the homework problems, all the problems in the textbook I didn't assign for homework if you want more practice. You got the group activity problems in the packet, the even more practice problems in the packet, and then the separate packet of practice problems for the whole semester. Additionally, you now have 2 quests. That's another good source of problems. Don't just go over the ones you missed and figure out what went wrong, but also look at the ones that you did correctly and just make sure you haven't forgotten how to do them. Any questions on the calendar? Okay. So let's jump in here on the top of page 93. In this lesson, we look at applications of systems of linear equations. These applications involve total value and investment problems. So 2 kinds of problems today. Number 1, 2 types of candy sell for $2.50 per pound and $4 per pound. So you're picturing like a candy store, and it's not the prepackaged stuff, but rather you can just like take a scoop of, like M&Ms and a scoop of something else and mix it all together in one bag. So 2 kinds of candy, and the clerk is trying to make a mixture worth $11.70 altogether. So some of the $4 stuff and some of the $2.50 stuff, but with twice as much of the cheap candy as the expensive candy. And it turns out there's only one way to do that, only one combination, so many pounds of the cheaper stuff and so many pounds of the expensive stuff, where you have twice as much of one and it's worth $11.70 exactly. How much of each type of candy should be included in the mixture? So we're going to answer that question through the course of this page right here. So our steps, our first step is the same as it has been for other word problems, is to define a variable. And if you look real carefully, I am telling you what the variable should be. How much of each type? How much of each type? So we're going to let C equal the number of pounds of the cheaper candy, and E equal the number of pounds of the expensive candy. It's not the cost, it's the number of pounds. You are answering how much. Okay, so we've got our first of many charts today, so let's see if we can start filling this thing in. We'll begin with that middle blank column. It says cost per item, and in the first row here we've got cheaper candy. So we're just filling out the cost per, I guess it's not really item, but it's per pound in this example. So how much does the cheaper stuff cost per pound? $2.50. I'm just going to write that as 2.5. And then the expensive candy, how much per pound? $4. And the bottom row you can see is labeled total. It doesn't really make sense to add the 4 and the 250. There isn't any candy that costs $6.50 a pound in this example. That one will get left blank. Okay, let's take a look in the first column, number of items. Okay, this is kind of a generic table up here with the headings at the top. It's really number of pounds in our case. So the number of pounds of cheap candy, well, that's one of our variables. What do we call it? C. And then the number of pounds of expensive candy, what did we call that? E. And in the bottom row, it is a total. And in some problems, you're going to have a number given in the words that you fill in that blank. Do we know how many total pounds of candy we're after in this problem? No. But in other cases, it might just be written explicitly. We want 15 pounds of candy altogether, and you just plop the number 15 in there. But in this case, it's a blank. All right, last column says total value. Suppose for 1 second that I say that we have, I don't know, 6 pounds of the expensive candy. How much is that? How much is the value of that 6 pounds of candy? $24, yes? 6 pounds of candy at $4 per pound. So we just multiplied. Well, that's what we're looking for here. Don't write this, but like if it were 6 pounds, then it would be $24 worth of candy, the value of that candy. But I'm not putting that because I just made up 6, but it's really E. And so what I'm supposed to put over here isn't 4 times 6, but 4 times E. That's what goes in this last column. 4E right there. Everybody see it? That's not a number of pounds. That is a dollar amount. It's the value of just the expensive part of the candy that's in this mixed bag. How about the value of the cheaper candy? 2.5 times C, right? $2.50 times the number of pounds, we call that C. And 2.5C is the value of that candy. And I will make this observation here and again later, but to get this last column, it turned out all we had to do was multiply the first 2 columns, right? 2.5 times C, that's what went here, and 4 times E, that's what went there. And the way that we set up our tables, it's going to be that pattern every time. The word problems are going to change, the context will change quite a bit, but it's going to be very common for us to multiply the first 2 columns and put the answer in the last column. That said, I don't want you to memorize that pattern. I want us to really understand why that's a reasonable thing in each of the different problems we do today. Okay, total value, bottom row is the total mixture. It's a number. How much is the value supposed to be for this bag? It is 4E plus 2.5C. For sure, that is the value of the bag. But as a number, it's also given in this problem. What's it worth? We are trying to make something worth $11.70, yeah? But Kara's got it exactly right. We know that the total value is just the 2.5C plus the 4E, whatever that works out to be. And we also know the total value is $11.70. And so putting those 2 things together in one equation gives us this guy right here. Okay? That is one of our equations. 2.5E plus 2.5C plus 4E equals 1170. Yeah? Okay. Well, that's one equation, but we need a second one. All right, I guess if your eyes have moved just a little bit higher than what I've highlighted, you see the second one, but pretend you don't know that one for right now. I'm going to write 2 equations right up here. E equals 2C and C equals 2E. And here is the phrase we are looking for. We want twice as much cheap candy as expensive candy. And to me, that feels very much like one of the variables is twice the other. And so I've written both possibilities for one variable being twice the other. Okay, well, what do we think? Twice as much cheap as expensive. If I just read it, like word for word, twice as much cheap feels to me like 2C, 2 times C. And the 2 times C equation is this first one, E equals 2C. Sadly, that is not the correct equation. This is a case where the English language isn't doing us any favors. When we say there's twice as much cheap as expensive, which one is the bigger? Which one has more? Cheap or expensive? The cheap one is more, right? This is really saying the cheap one is twice as many as the expensive one, yes? And that is given by the second equation. The cheap one is twice as many as the expensive one. And there's going to be times when, like I said, the English language is just kind of leading us astray. So you have to read very carefully as you translate. So it is not this equation at all. It is C equals 2E, okay? All right, so we've got our 2 equations. They're typed up down below the table. And then we have to use the techniques from our previous class, either substitution or elimination. We're not going to do that for this problem right now, but if you want more practice after class, you can solve this one. I've told you the answer. Turned out to be 2.6 pounds of the cheap stuff and 1.3 of the expensive stuff, okay? All right, so the other problem in the demo is on the next page. It has to do with interest. It says the amount of money that's deposited in a savings account is called the principal. And then the money a person earns from the bank is called interest or interest income. So put your money in the bank and you get interest as a result of keeping that money in the bank. If money is invested for 1 year, then the interest equals the principal times the rate. Interest equals P times R. So I want to convince you that you know this formula, even if you don't have it memorized as a formula. Suppose that I tell you that you put $600 into a bank at 10% interest per year. By the way, that's roughly 1,000 times bigger than the interest rates that are currently available at banks. So I'm just making up a totally not realistic number. And I'm not exaggerating when I say literally 1,000 times bigger than current interest rates. Okay, so how do we calculate how much interest you get after 1 year? $600 times the percent, right? It's just 10% of 600. Okay, so 10% of 600 happens to be 60 bucks. But the important thing is that you just need to multiply 600. Let's say that the interest is equal to the $600 times, and then we wouldn't write the number 10% here. What number would we write? 0.10, right? Because we know we need to convert our percents to decimals when we use them in this way. And that's it. That's what the formula says. This 600 is the principal, the 10% is the interest rate, and it just tells you that the actual amount of interest is the principal times the rate. So it's something we know to be true, even if we don't have it memorized with the letters. Okay, so let's take a look at number 3. It says Jerry invested a total of $2,000 in 2 different banks. The first bank pays 4% interest, and the second bank pays 9% interest. His yearly income from the 9% investment is $37 more than his yearly income from the 4% investment. How much did he invest at each rate? Okay, first step is just like before. We need to define some variables. It's written there, but don't read it just yet. The question says how much at each rate. Those are your variables. How much at each rate? So some of that money went to the 4%, some of it went to the 9%, and we're just going to call L and H the amount in dollars. Got to have our unit word invested at the lower rate and the higher rate, respectively. Notice that I'm using L and H and not X and Y. And in the previous problem, we used C for cheap and E for expensive. And you're welcome to use X and Y on every problem today, but I think it's worth using letters that remind you of what they stand for. Number 1, going back to the cheap and expensive candy, right in here, when we filled in this thing, it was obvious, right? We didn't have to think about it because C stood for cheap. So of course you put that in the row that says cheap. But if X were the thing for cheap, then you'd have an opportunity to maybe make a careless mistake, put the X and the Y in the wrong spot. And if you do that, you're going to get the wrong answers. The equations just aren't going to work out. Additionally, remember how we talked about that equation being reasonable, but it was really that one that was right? And we had to piece our way through. Well, imagine if it were X and Y standing for the cheap and the expensive candy. That's another hurdle that we have to go through mentally, right, to figure out which one of these 2 equations is the right one. I think it's hard enough with C and E. So I recommend, but don't require, that you use letters that remind you of the things they stand for. It's also nice to have those letters standing for the things when you have to write a sentence, which you'll do for me today. But at the end of the game, in this one, it says that C turned out to be 2.6 and E turned out to be 1.3. And so when you go to write your sentence summarizing, 2.6 pounds of cheap, well, you don't have to think about it. It's clearly written there. Whereas if it was just X and Y, one more opportunity to maybe make a careless mistake and put them in the wrong order when you write your sentence. Okay, so we've got L and H, and we're going to start filling in here. Okay, first up, interest rate for low. This is just a number. What is it? It is 4%, but we're not going to put the number 4. What number are we putting? 0.04. The decimal point 2 places. Okay, and then right below that, the high interest rate is 9%, so that's 0.09. And then the total, it's 0.13, but that doesn't have any meaning in this problem. I'll cross it off. In the first column, These are just our variables. What are we putting for the top blank? L. It's the amount of money invested. That was just L. Bottom one is H. And then down below it says total. Do we know how much we invested in total? We do. How much is it? 2,000. That goes there. In the candy problem, that was blank. We didn't know how many pounds of candy altogether. But here we know how much money altogether. Okay, and then the last column, amount of interest income. Let me just remind you that the amount of money invested, we said, is called the principal, P. And then these interest rates up above, we used the letter R to represent them. And our formula up above says if you take the principal and you multiply it by the interest rate, what do you get? What do we get? The interest, right? That's what we called I up above in that formula. Yes? I equals P times R. So how do we get the last column in this table? Well, we just multiply the first two columns. So 0.04 times L and 0.09 times H. Just like before, I said that in these tables, we're going to multiply the first two columns and put it in the last column, but I really want you to understand why that's the right thing to do. It's this formula. If you invested $600, not L, but $600 at 4% interest, you would just multiply those to figure out how much interest you had at the end of the year, right? That's what we did with the $600 and 10% example. So we just multiply them. So that 0.04L, it is not an interest rate, that is a dollar amount. That's how much interest we get at the end of 1 year. Okay, are we told the total amount of interest for these two banks? There's a 37 in this problem. Is that the total amount of interest from the two banks? No, we're not told the total. But that 37 is somehow important. We're going to have to write an equation. But before we write that equation, let's write the easier equation. Okay, so the first column gives you one equation. You invested L dollars, and separately you invested H dollars, but altogether you invested $2,000. So what's the equation there? L plus H equals 2,000. Right? That's just reading down the one column. All right. We can't read down any other columns because these other two bottom row entries are blank. So what we have to do is translate. And we're going to translate this sentence right here. And this is the hardest translation that we'll do today, even in all the activities. This is as tough as it gets. So let us carefully translate. Yearly income from the 9% investment is $37 more than the yearly income from the 4% investment. We're going to take this piece by piece, starting right here. Yearly income from the 9% investment. Stop reading. That phrase is represented in the table. Which entry represents the yearly income, the interest income from the 9% investment? That's the 0.09H. That's it. It's some dollar amount. I don't know what it is, but it is represented by 0.09H. This is the start of my equation. Next thing is, stop reading. What symbol? Equals. Next clause, $37 more than. Stop reading right there. What symbols am I writing? 37 plus. See it? 37 more than. Last phrase, yearly income from 4% investment. That's in the table. Where is it? 0.04L. That's the equation. That is as hard as they get in terms of translating words into equations. But if you take it piece by piece, I think it's manageable. All right, so in this case, we've got two equations. L plus H is 2,000, and then the more complicated one we just figured out. Again, we're not going to solve this here. You could either try substitution, or if you wanted to do the elimination method, you'd probably want to bring this 0.04L to the left-hand side. For the elimination method, we like the L's right above each other and the H's right above each other. So I would move that term to the left-hand side. Another thing you're welcome to do, but you're not required to do, is that if you don't want to deal with all of these decimals, you can multiply this whole equation by some magic number that will get rid of all those decimals. What magic number will do it here? 100. 100 is the magic number because we know multiplying by 100 takes that decimal point and moves it 2 places to the right. And so this equation becomes what happens on the left-hand side. 9h equals what? 3,700. Don't just leave that as 37. Everybody times 100 plus 4L. No more decimal points. Maybe that's a little bit more friendly to work with. Any questions on that example? Okay, this is all kind of written out generally on the next page. You can come back to that as a reference if you wish. So let's jump to the activities and I'll point out 2 things. Number 1, I have provided you a table, but what have I not provided you with in that table? Labels. I haven't given you anything. It's just a blank table. I haven't given you anything. This is what it's going to be like on the test. In fact, I don't even think I'm going to give you a blank table on the test, but you can draw one if you want. But you're going to need to take your time coming up with label headings, like for the columns and for the rows. And it was like, it looked easy when it was all typed out for us in the demo, but take your time. There's work involved in figuring out what the labels should be. Okay, so here's what you're going to do. Kind of unusual instructions. You are going to set up the equations for one problem, meaning get to the place where you have 2 equations written out. But before you solve those by either substitution or elimination, skip to the next problem and do all the work associated with just creating the equations. So what I want you to do for the 5 problems in this activity is get the equations and move to the next problem, get the equations and move on. And once you've got the equations for all 5, go back to the first one and then start solving, okay? All right, raise the flag if you get stuck.